Hello, everyone, and welcome to our lesson of today. This is lesson number 3 of ratios. Now, we are going to be looking at ratios of many numbers. Ratios can be used to make comparisons among 3 or more quantities. What we have been looking at is comparing two quantities. But now you can see that we can also compare 3 or more things, okay, using ratios. Let us see an example. If x is equal to 18, y is equal to 27, and z is equal to 54, then find the ratio of x to y to z. B, x to y. C, y to z. And D, x to z. Okay. Now, we are having x to y to z. But we know that x is 18. Y is 27. Z is 54. Look at that ratio. Can we write it in the simplest form? Do we have any common factor that we can use for 18, 27, and 54? Yes. What do you think? I think yes. So if we use 9, we can get 18 divided by 9 to 27 divided by 9 to 54 divided by 9. You see? Let me use a different color to make this clear. Okay. Now, when we get 18 divided by 9, we are going to come up with 2. 27 divided by 9, we get 3. And 54 divided by 9, we get 6. You see that? So our ratio becomes 2 to 3 to 6. Okay, 2 to 3 to 6. So it means that x to y to z is equal to 2 to 3 to 6. Okay. Now, how about the ratio x to y? X to y, we see that x is 2, y is 3, and z is 6. Okay. Now, it means that if we need x to y, x will be 2 and y will be 3. So that will be 2 to 3. And part C, we need y to z. Now, y is 3, and z is 6. Now, when you look at this ratio, 3 to 6, you see that it is not written in simplest form. So we have got to go ahead and write it in simplest form. Now we will say that this is the same as 3. So we get the common factor of 3 and 6, and that will be 3. So we get 3 divided by 3. So 6 divided by 3. You see that? And now this will be equal to 3 by 3, that is 1, and 6 by 3, that is 2. So this means that the ratio y to z is the same as 1 to 2. Let's write it here. Y to z is equal to 1 to 2. Okay. Part D, we need to know the ratio x to z. Now, x is 2 and z is 6. Now, still you see that 2 to 6 is not in simplest form. So we have to go ahead and make it the simplest form. So we get the common factor of 2 and 3, that will be 2. Now we need to get 2 divided by 2 to 6 divided by 2. Now, 2 by 2 will give us 1. Let me write very well these equal signs. 2 divided by 2, we get 1. And 6 divided by 2, we get 3. So that we get 1, 2, 3. I hope you have understood that very well. Okay. Let us see another example. If x to y is 11 to 8, and y to z is 6 to 7, calculate the following. Number 1, x to y to z, and number 2, x to z. Okay, let's get our solution here. We have been told that x to y is 11 to 8, but y to z is 6 to 7. How can we know x to y to z? Okay. Now, we know that x to y means 11 to 8. But at the same time, we know that y to z is 6 to 7. Look at that. You see that y is appearing 2 times. You see, this is y and this is y. In the first part, y is 8, and in the other part, y is 6. Now, let us get the LCM of y that is 8 and y that is 6. So we get the LCM of 8 and 6. You get the LCM of the number that is appearing 2 times. Like you get the LCM of the common ratio. Sorry, the common number. So here you see the common number is 8 for y and 6 for y. Okay. In other words, you get the common part in the ratios, x to y and y to z. So the LCM of 8 and 6 is 24. Okay, that is the LCM. Now, we are going to get the new ratios. Okay, so we are going to have x to y and y to z. The LCM is 24. You see that to get 24, we need to multiply 8, this 8 by 3. So it means the whole of it, we are going to multiply it by 3. And when we have 6, to get 24, we multiply by 4. You get that? Now, this implies that we are going to get 11 times 3. 11 times 3. And again, we get 8 times 3. So we are getting 11 times 3 to 8 times 3. Okay? And this will be 33 to 24. In this part, we are going to have 6 times 4 to 7 times 4. 6 times 4 is 24, and 7 times 4 is 28. Now, you see that at this point, y is 24, and here y is 24. There it becomes easier to write the whole ratio at once. So we come and say that finally, x to y to z is 33, which is for x, okay, y, which is for 24, and z, which is 28. So that is our final answer. X to y to z is the same as 33 to 24 to 28. I hope you understand that very well. We are not writing this, we are not continuing to reduce it because we don't have a common factor of 33, 24, and 28. We don't have that common factor. So that's why we have to stop there and say that therefore x to y to z is equal to 33 to 24 to 28. Okay. Let's look at part 2. X to z. X to z. Okay. How do we get that? We are seeing that x is 33. And we are also seeing that z is 28. So we are going to have our answer as x to z will be 33 to 28. And since we don't have any common factor for 33 and 28, we are going to leave it like that. Okay, let us see the application. How can we use the ratio of three numbers in real life? Look at this example. The ratio of James's age to John's age is 2 to 3. And the ratio of John's age to Jack's age is 5 to 4. Find the following. Number 1, the ratio of James's age to John's age to Jack's age. Okay, the ratio of James's age to John's age to Jack's age. Then the ratio of John's age to the sum of their ages. Okay, let's begin with part 1. What do we have? James's age to John's age is 2 to 3. John's age to Jack's age is 5 to 4. That is the information that we have. Let's write it down. We have James's age, James to John is 2, let me use another color, is 2 to 3. Then John to Jack, John to Jack is 5 to 4. 5 to 4. Now, what is the common part in these two ratios? You see, the common part is John. We have John here, and again we have John here. You see that? Now, this implies that we need to get the LCM of 3 and 5. The LCM of 3 and 5, that will be 15. Okay. Now, this means that this part, we are asking ourselves, what number can we multiply by 3 to get 15? Of course, that number will be 5. And for this part, what number can we multiply by 5 to get 15? Of course, that is 3. Now, let us rewrite the ratios. This ratio of 2 to 3, it will become 2 times 5, 2 times 5, to 3 times 5. And this will be 10 to 15. Then, on the other hand, this ratio 5 to 4 will become 5 times 3, 5 times 3, okay, to 4 times 3, 4 times 3. You get that? And we know that 5 times 3 is 15, and 4 times 3 is 12. Okay, now you see that we are getting 15 and 15. Don't forget that this 10 is for James. To 15, it is for John. Then this 15 is for John, and this 12 is for Jack. Okay, now you see that we are having John as 15, and again here, John as 15. Now let's rewrite the ratio. We need to know James to John to Jack. Okay, now James, we are seeing that it is 10, this one. John, it is 15. Jack, it is 12, this one. Okay. Do we have any common factor of 10, 15, and 12? No. Since it is not there, then this will be our answer. We can say that finally, the ratio of James's age to John's age to Jack's age is 10 to 15 to 12. Okay, let us get the final part of our lesson. Find the ratio of John's age to the sum of their ages. Sum. And then John's age. What is the sum of their ages? James is 10, John is 15, Jack is 12. So we are getting 10 plus 10 plus 15 plus 12. And this will give us 37. Okay. Now, we need to know the ratio of John's age to the sum of their age. So this will be John's age, which is 15. Okay. To the sum of their age, which is 37. And this becomes your answer. Okay, I hope you have understood how to deal with the ratios of many numbers. Okay. Do practice on page number 9 to number 10. Practice is on page 9 and 10. So we stop here for our lesson of today, and we meet again next time to look at proportions. In the next lesson, we are going to be looking at proportions. Let's stop here and we meet.